Hello everyone and welcome to Byju's Exam Prep IAS. Today we are going to start with the sessions on science and technology, and during the next 3 days we'll take up some of the key areas related to science and tech which have appeared in one way or the other in your current affairs. Some of these topics have been very crucially important. Some of these topics have been discussed widely in the newspapers, and there are some topics which are not really have been discussed in the newspapers, but nevertheless they have been important because they have been discussed in the scientific world. So we have tried to compile these areas. We have tried to compile these areas from where questions could be asked. And also, it's not about only these questions which are here in this paper, but at the same time, all the topics that we are going to discuss here. So all these topics that we are discussing, directly or indirectly, they can be important for your examination. So that's why we have to keep in mind that it's not only about these questions that we are going to discuss here, but at the same time it's also about all these areas and keywords that we are going to learn. So what I'll also do during looking at all these questions is the fact that when we are looking at these questions, we'll try to analyze the questions, we'll try to understand how we are arriving at the answers, but at the same time I'll also list out some of the key areas which can be important for your examination, from where while you are doing your last minute revision for your exam, you should revisit all these points as well, all these concepts as well. So this is what we are going to do. In today's class, specifically there are two topics from where I have picked questions. One is space technology. Space technology is perhaps the most crucial part of your preparation, because if you look at all the previous year papers, you'll see that most number of questions have appeared from space technology. Every year, we do expect that at least one question would come from space technology. And the second topic that we are going to discuss in today's class is about AI and robotics, that is artificial intelligence and robotics. So these are the two areas from where we have compiled the questions for today's class, and we will look into all the concepts which are behind these questions and some of the way forward, or you can say other areas which are also related to what we are going to discuss in today's class. So let's begin with the first question and understand what exactly do we need. So first and foremost, the first question is, consider the following statements with regards to Canadian Hydrogen Intensity Mapping Experiment or CHIME telescope. One, it is a radio telescope in Canada, and second, it is used for studying the sun's magnetic field. So these are the two statements given here. Now, first and foremost, if we look at this particular telescope, that is CHIME, let's try to understand what it is. So if you look at this picture, this is a picture of the CHIME telescope or CHIME radio telescope. What exactly it is supposed to do? It is supposed to map the intensity of hydrogen. Now, what do we mean? What is the requirement? Why do we need to map the intensity of hydrogen? If you go back into the early history of the universe, if you go back into the early universe, you'll find that this is where we find that hydrogen was the first atom to start being made up. From the subatomic particles like the quarks, etc., the first atom to be made was hydrogen. And ever since then, hydrogen has existed in the universe. Whether it is the early universe when the size of the universe was very small and it was very chaotic, or coming to the current scenario where we have a pretty stable universe. So whether you talk about the early universe or the present universe, you will find that hydrogen has been a major part of the universe. If you look at the mapping of the universe in the current scenario, you will see that almost 4% of the universe is only freely existing hydrogen and helium. Now 4% might look like it's a very small number, is it? No, it's not a small number, because when you look at the universe, when you try to understand the structure of the universe, you'll find that most of the things that you can see around or you can observe in the night sky, you'll see that most of these are maybe 0.5% or even lesser than that. So all the, for example, just to put things into perspective, all the stars in the universe combined, they are just 0.5% of the universe. All the stars, whether you see them or you don't see them, all the stars combined, they are just 0.5% of the universe. So now if you compare that to almost 4% being hydrogen and helium, that's a big number. So that's why hydrogen has been a major part of the universe all throughout the universe. So that's why mapping the intensity of the hydrogen would also give us some idea about what the universe has been, how the universe has grown, and how it has changed over the years. Over the years, when I say, it's almost 14 billion years. So when we are looking at this number, we know that this number will give us some idea about how the universe has also evolved since the time of its birth to the present scenario. So this is why we are trying to map the intensity of hydrogen, because it will give us some idea about what exactly the universe is, and it might also give us an idea about how the universe has evolved. Now, why exactly was SHIME in news? The reason why it was in news was that in the first year of its operation, it detected more than 535 to be exact, 535 fast radio bursts. Alright. So two things that are important from perspective of SHIME. One is intensity of hydrogen, and second is about fast radio burst. So intensity of hydrogen we understood. Why intensity of hydrogen? The second thing is fast radio burst. What do we mean by fast radio burst? These are, you can say in a manner, bursts of radio waves which have been observed in the universe. Now what is the origin of these fast radio waves? Good thing is we don't know. We don't know what the origin is, and that's why, let's say in the prelims examination, if anything is asked about fast radio bursts, because if you look at the last 1 year of your newspapers, you will see that fast radio bursts have been mentioned in your newspapers at least twice or thrice. So that's why it is a concept which has been in news. So that's why fast radio bursts. What are fast radio bursts? These are bursts of hydrogen, all right, bursts of radio waves, and these radio waves have been found in the universe. They have been detected in the universe. The first detection happened almost 15 years back in 2007, and since then there have been instances where fast radio bursts have been detected. And last year SHIME also had detected these fast radio bursts. So these fast radio bursts, they are highly energetic. They emit a lot of energy. How much energy? You can say almost amount of energy that is emitted by the sun in 3-4 days. So that much amount of energy is emitted by fast radio bursts in just 1 millisecond. So that's why they are fast bursts of energy that are emitted from some sources due to some astrophysical phenomena that we don't know. We do not know what is the origin of these fast radio bursts. So this is one key thing that you should not, you should understand, that it should not become a trap for you, because if they, let's say, give you a sentence about fast radio bursts, that fast radio bursts originate from, let's say, black holes or something like this. Wrong, because we do not know where they are coming from. We know that they are coming from somewhere, but we do not know what the origin is. So that's why these are the two key concepts when it comes to SHIME. So let's move back and look at what the question is. First is, it is a radio telescope in Canada. Is it? Yes, it is. That is true. It is a radio telescope in Canada which is basically used to detect or measure the intensity of hydrogen. Second is, it is used for studying sun's magnetic field. Now it is nothing to do with sun's magnetic field. What is it studying? It is studying hydrogen intensity in the universe. So that's why nothing to do with sun's magnetic field. So if we look at the options given, the first is correct, the second is wrong. So that's why the correct answer here will be 1 only. Correct answer will be B, that is 1 only. So this is what it is. This is what we mean by SHIME. So just remember a couple of things which are going to be important for you. One, that it measures the intensity of hydrogen. Second, fast radio bursts were detected here. One more thing, it is also related to dark energy. Because here we are talking about the evolution of the universe, the structure of the universe, and dark energy is a very key concept behind the expansion of the universe. So that's why it might give us some ideas about dark energy, or give us an understanding about what dark energy might be. So that's why from that perspective, when we look at this, we can say that even dark energy as a concept becomes important related to this current affairs. All right. So this is what it is about the first question. Let's move on to the second question. Consider the following statements with respect to James Webb Telescope. It is being viewed as a successor of Hubble Space Telescope. It is a joint collaboration between NASA, European Space Agency and Japanese Space Agency. And third, it has been or it will be put into L2 orbit. Alright, so these are the three statements given here. So we are talking about the James Webb Space Telescope. Now James Webb Space Telescope, this is how James Webb Telescope looks like. Again, very important from the examination perspective, because James Webb Space Telescope is something that has been under construction for almost 30 years, more than 30 years now, almost 35 I can say. So almost 35 years it has been under construction. Finally it has been launched. Was initially supposed to be launched in 2018, then 19, pushed to 2020, pushed to 2021. Finally, before the end of 2021, on the eve of Christmas, 25th December 2021, it was finally launched. And this is very significant. Why are we calling James Webb Space Telescope to be very significant? The reason why we are saying that it could be significant is the fact that this is for the first time that we have launched something that may give us an idea about the early universe. James Webb Space Telescope, according to scientists, might give us an idea about the early universe. How come? How exactly will it give us an idea about the early universe? Because the instruments that have been placed here, the telescope itself, the mirrors that have been placed here are highly sensitive, and they might be able to go across the universe, give us an idea or give us pictures and observations about the universe that none of our instruments have ever given us. So that is why it becomes such an important telescope. Also, we have been saying that it is a successor of the Hubble Space Telescope. Hubble Space Telescope has been operational for more than 30 years now, and many of the pictures and many of the observations that you know about the universe today, it is thanks to Hubble Space Telescope. So that's why from that perspective, Hubble Space Telescope has been very important. It is still functional. Remember that it's not that Hubble Space Telescope is not working anymore. It is still functional, but James Webb Space Telescope becomes the successor of Hubble Space Telescope. Once the operations of Hubble Space Telescope stop, James Webb will take over as a full-time successor of Hubble Space Telescope. The first pictures are still awaited. The first full color images from James Webb Space Telescope perhaps will come in the month of July. Has been operational for almost 6 months, reached its orbit in the month of January, and since then we have been looking forward to receiving images from the James Webb Space Telescope. Now James Webb Space Telescope, another key point about James Webb Space Telescope is where exactly it is located. If you look at this particular picture, this is where James Webb is. So you have the Earth here, you have the lunar orbit here, and James Webb is placed at an orbit called as L2. Now what is L2, what is L1, etc. We'll have a good discussion on it when we go to another question which is related to Aditya L1. We'll look into that, but for now just know this, that James Webb Space Telescope has been put to an orbit which is called as L2 or Lagrange point 2. What are Lagrange points? We'll have a discussion on it. Please don't worry about that. So this is where it has been kept. So few things which are important. One will give us an idea about early universe. All right, seen as successor of Hubble Space Telescope. And one more thing, one thing that you must remember is the fact that it will take its observations in the infrared zone. So that's why its operations will be, or its observations will be, in the infrared part of the electromagnetic spectrum. So these are few things which are really important from perspective of your prelims. So let's revisit what the question is. First, it is being viewed as a successor of Hubble Space Telescope. Yes, this is true. It is a joint collaboration between NASA, European Space Agency and Japanese Space Agency. Now this is not correct. Japanese Space Agency is not involved here. It is the third one which is involved is Canadian Space Agency. So that's why saying that Japanese Space Agency is involved would be wrong. So that's why this is something that you must remember. And then finally it will be put into L2 orbit. This is correct, that it has been put, rather it has now been put in the month of January, it has been put into the L2 orbit. So that's why first one is correct. The second one, because Japan is not involved and Canadian Space Agency is involved, so that's why this is wrong. Third sentence or third statement is correct. So what are the correct statements? The first one and the third one. So that's why the correct answer here will be C, that is 1 and 3 only. Alright, so this is what it is about James Webb Space Telescope. Moving on, the next question with reference to Parker Solar Mission. Consider the following statements. 1. It is the first ever mission to touch the sun. Mission is a joint collaboration of NASA and European Space Agency. Third, mission aims to detect the flow of energy that heats the corona. Alright, so these are the three statements that have been given about Parker Solar Mission. Now, when Parker Solar Mission is also supposed to be important, although launched back in 2018, but ever since then we have been expecting questions from here. We haven't really seen any question until now in your prelims, but still remains important, because if you just search the newspaper of last 1 year, you will see that there are at least 3-4 instances where this has been mentioned, where Parker Solar Probe has been mentioned in the newspaper for one reason or the other. Now, this you have to understand that this is a remarkable mission. This is a remarkable mission mainly because of the fact that this is where we have been able to reach the sun, and reaching the sun is no small play. It has taken more than 35 years of you can say it has taken more than 35 years from NASA for them to be able to come to a place where they would be able to launch such a mission, where the mission is going so near to the sun and yet surviving. It has been sending back data from there, and which is remarkable, that you are just standing next to the sun and you have not lost your contact. You have not just given in to the radiations and the heat coming from the sun. So that's why this is a remarkable mission, and it has taken more than 35 years of efforts from the side of NASA to reach a point where they have been able to launch it. So that's why this is remarkable. This is remarkable, and that's why this is something that needs to be taken as, you can say, one of the pinnacle of success when it comes to space technology. So what exactly it is supposed to do? It is going near the sun, trying to understand the atmosphere of the sun, trying to understand the conditions that exist there, not only the conditions of the atmosphere of the sun, but at the same time also to understand what exactly or how exactly is the magnetic field, or how does the magnetic field of the sun behave, and some of the key areas which are not very well understood until now by us. So we'll try to understand all these things. We'll try to understand how exactly all these things function through the Parker Solar Mission. So that's why the first mission to touch the sun, it is true. Why we are using the word that it is touching the sun? Because it has almost entered the atmosphere of the sun, which is remarkable that it is in the atmosphere of the sun now. Mission is a joint collaboration of NASA and European Space Agency. Now here we do not see anything, we have nothing to do with European Space Agency. It has been a project that has been taken by NASA alone, so that's why we can't say that European Space Agency is involved. Mission aims to detect the flow of energy that heats the corona. This is correct. Now one thing, just remember this. Let's say the only, there could have been another way of putting the things, that let's say that the only way or the only mission that this, or the only aim that Parker Solar Probe has is to detect or to look into the flow of energy that heats the corona. If let's say the word only was used here, then this would have been wrong, because it is just one of the missions, one of the aims of the Parker Solar Mission. So that's why you have to be very mindful and always, and we'll look into other questions as well where we'll see these words coming back. Always remember that if these kind of words appear in your paper, then these kind of words have to be read, or these kind of statements have to be read at least twice or thrice before you come to an answer, before you come to an understanding that whether or not this is correct. So that's why, because they have not said that this is the only aim, that's why this is a correct sentence. Otherwise we would have said that this is not correct. So first statement again is correct, second is wrong, third is again correct. So that's why the correct answer here again will be 1 and 3 only. So if you look at the Parker Solar Mission, it has reached very near to the sun. Some of the key things: one, that it is going to study the solar atmosphere. It is going to study the solar atmosphere. One thing that is very, very important when it comes to the Parker Solar Mission is the fact that it has taken something which is called as Venus flyby. Venus flyby, or something which is also called as gravity assist. Gravity assist. So Venus flyby or gravity assist. Now this word gravity assist is something that what we mean is that while it is going to the sun, it has taken assistance of the gravitational field of Venus. So basically, let's say if this is the sun and from the earth it is being launched and you have Venus here. So what happens is that while it is being sent, it has taken a help from the gravitational field of Venus, and with this help it has been able to be launched to the sun, or it has been able to reach the sun. So that's why this is something which is called as gravity assist or Venus flyby, that it has taken the assistance of the gravitational field of Venus, and with that help it has been able to reach near the sun. Alright, moving on. In the context of small satellite launch vehicle, consider the following statements. It can carry satellites weighing up to 250 kg only, and it will launch the satellite into low Earth orbit. Again, very, very important, small satellite launch vehicle. Small satellite launch vehicle is something that is, you can say, the next generation launch vehicle of ISRO. If you consider the launch vehicles of ISRO, we know that we have two important launch vehicles. One is PSLV and the other one is GSLV. And these two are the launch vehicles which are being used by India. Now, with this small satellite launch vehicle, ISRO now wants to enter the commercial space. Until now, if you look at all the satellites which have been launched by ISRO, you'll see that all these satellites are application-based satellites. Some way or the other, they are related to the applications related to the Indian society, for the betterment of Indian society. But now we are entering a space which is commercial. So whether you consider any communication satellite or all the Earth observation satellites, all the navigation satellites that we have launched until now, they have been related in one way or the other. They have been related to what? They have been related to applications for the Indian society. But now with small satellite launch vehicle or SSLV, we are trying to enter the commercial space. In what sense are we entering the commercial space? We are trying to enter the commercial space in the manner that any private company, whether domestic or foreign, if they want to launch their own satellites, they can now come to ISRO. They can come to ISRO and they can get their satellites launched. So for getting their satellite launched, they have to come to ISRO, they have to put in their request, and if this is accepted by ISRO, they can launch their satellite with the help of ISRO. And this basically will be done for the small satellites. And that's why what we are considering here are small satellites. Remember this, that this is something for the small satellites. Now what do we mean by small satellites? Small satellites, first of all, according to ISRO, the definition for small satellites are all the satellites which are less than 500 kg. All the satellites which are less than 500 kg in mass, they are called as small satellite launch vehicles. Alright. So now in this case, when we call about small satellite launch vehicles or small satellites, in all these small satellites, remember that there are various categories. We have something called as mini satellites, we have something called as micro satellites, then we have nano satellite, very key aspect of small satellites, and then we have pico satellites. Now this is basically done on the basis of what is the mass of the satellite. So for example, anything that is between 100 to 500 kg, they would be called as mini satellites. Anything that is between almost, you can say, 25 to 100 kg, they would be called as micro satellites. Between 1 to 25 kg, it would be called as nano satellite, and anything that is lesser than 1 kg would be called as pico satellite. Alright, so these are basic categories of small satellites, and all these categories of small satellites can be launched using small satellite launch vehicle. So that's why any satellite that is lesser than 500 kg in mass can be launched with the help of small satellite launch vehicle or SSLV. So this is what the basic agenda of SSLV is, that SSLV is trying to with SSLV, ISRO is trying to enter the commercial space. Now one thing which is again very important with regards to SSLV is the name, that is New Space India Limited or NSIL, because NSIL will be the nodal agency which will basically look after the operations of SSLV. So any requests that have to be put in, they have to be put through NSIL, and NSIL has been just established a couple of years back. It was just in 2019 then that NSIL was established as a commercial arm of ISRO to look into the privatization part, or not rather privatization of ISRO, but rather privatization of space technology, that so that more of public-private partnerships can happen in India, more private partnerships can happen in even the launches that are being done by ISRO. So for example, if you consider the launch that was done a couple of months back, you'll see that many of the components that were used in the PSLV and the satellite construction as well, they came from some private companies. For example, let's say Bharat Dynamics Limited. So these kind of companies, they also have started to collaborate with ISRO, and in this manner it has been able to fasten the entire process of making the satellites, of building the satellites faster. So that's why we have seen that more of private participation will start to happen in the space technology in the country, and NSIL will be trying to collaborate between all these partnerships. So that's why NSIL is an important name, and also IN-SPACe is another important name. So these two names will be very crucial when it comes to the private partnerships or private participations in the country. So that's why this is basically about small satellite launch vehicle. If we start looking at the question again, if we look at the statements first, it can carry satellites weighing up to 250 kg only. I told you, whenever you see these words, try to read the sentences at least twice or thrice and see whether these are correct or not. This is not correct, because we are saying that up to 500 kg of satellite can be launched, because small satellites will be launched. Then it will launch the satellite into low Earth orbit. This is correct, that it will launch the satellites into low Earth orbit. Two kinds of orbits we know, that either you can call it as low Earth orbit, a kind of polar orbit, or also sun synchronous polar orbit. Sun synchronous polar orbit. So either it will carry to the sun synchronous polar orbit or the normal low Earth orbit. These are the two orbits into which the satellites could be launched using SSLV. So yes, this is correct, that it will launch the satellites into low Earth orbit. So that's why the first statement given here is wrong. The second statement given here is correct. So that's why the correct answer here will be B, that is 2 only. So just remember some of the key areas with regards to what we are discussing here, and how exactly some of these concepts can be important for you from the examination perspective. So SSLV was actually supposed to be launched in the month of April itself, but until now we are still waiting for the launch of SSLV to happen, and we have to see when the launch of SSLV happens. Moving on, the next question on Gaganyaan, again something which is going to be very important for your prelims. With respect to Gaganyaan, consider the following statements. 1. It will demonstrate human space flight to low Earth orbit. 2nd, it will have an unmanned mission and a manned mission. 3. India will be the 3rd country to have a manned mission after the US and Russia. Now, again, Gaganyaan mission. When it comes to Gaganyaan mission, what do we have as a part of Gaganyaan mission? We know that in the Gaganyaan mission, what are we trying to do? We are trying to take the satellite into space, where we will take a couple of astronauts along with this mission. They would stay in the space for 5 to 7 days, conduct certain experiments, and once they have done that, they will be brought back, right? They'll be brought back to the Earth. So this is what we are trying to do with Gaganyaan mission, and you can say that this is in a manner our first human space flight. Until now, India has not taken any human space flight. You might remember the name Rakesh Sharma, but Rakesh Sharma was not carried by India. He was an Indian, but he was not carried by India, not by ISRO. So that's why here with the Gaganyaan mission, this is for the first time that a crew will be, a human crew will be carried to space by ISRO. And this is basically, you can say, the first step towards the future human space flights that we might take. So this is basically what we are trying to do with the Gaganyaan mission. That with the Gaganyaan mission, we will be using GSLV Mark III, and with the help of GSLV Mark III, we will be taking people, a couple of people to the space, where they'll spend almost 5 to 7 days in the space, and then after that they will be brought back. They will be brought back to the Earth. So as a part of, you can say, a demonstration for the future human space flight, this is the first time that we are taking something like this, a project like this. Now when we are looking at this particular project, one thing that is very, very important to remember for this project is the fact that for this project, what kind of experiments are we doing? One experiment will be related to microgravity. Right, related to microgravity. So what do we mean by microgravity? Microgravity is the condition where the gravitational force is very, very weak. When you are in space where there is no celestial body in the vicinity which will have a very strong gravitational field, then in that case you will say that these conditions are microgravity conditions. So here in the human space flight that we are taking, we would have inside the flight, we will have microgravity situations, and we will try to conduct experiments where we will try to understand how the human body responds to microgravity conditions and how different organisms respond to these kind of microgravity conditions. So we will try to understand microgravity, we will try to understand our responses or any organism's response to microgravity conditions. At the same time, the experiments will be also conducted with regards to understanding of the space environment, what space environment is like, how exactly do we need to understand, and whether in one way or the other can this understanding be important for us for the future. So that is what we are trying to do. Then apart from that, one key thing that you should again remember from the perspective of your prelims is about Vyom Mitra. So Vyom Mitra basically would be a humanoid robot which would be carried along with the human crew, so as to check how exactly we can, whether we can carry this or how we can do this in the future missions. Because if in the future ISRO plans a mission which is for the outer space, obviously we cannot carry humans to those kind of flights, because it would be life threatening for them, of course. So that's why we can't carry humans in those kind of flights. So this is where these kind of humanoid robots perhaps would be carried in the future. So that's why we are also trying to understand this. We are also trying to test this technology as well, and our understanding of whether or not we are successful with this. So this is basically what we will be trying with the Gaganyaan mission. Let's come back to the question. First, it will demonstrate human space flight to low Earth orbit. This is correct, that these people will be carried to the low Earth orbit. Now the people or the astronauts, they also have been trained. They had gone to Russia for a training and they have spent some 6 to 8 months there, and then after training they have come back, because Russia has an expertise here, Russia has an experience here. So that's why Russia is where they had gone. They had went to Moscow and then the trainings happened, and after trainings they have come back. It will have an unmanned mission and a manned mission. Yes, both are a part of it. Before we take the manned mission, we want to take an unmanned mission as well, so as to test the exact technology, test the exact conditions, so that we are very sure that this is a safe flight. We can't put human lives in danger, of course. So that's why first we will have an exact same replica, which will be an unmanned mission, and then after that we will take a human space flight, and with this human space flight we will try to do our very first human space flight, and which will also demonstrate human space flights for the future. So yes, this is also true. India will be the third country to have a manned mission after USA and Russia. Now this is not correct, that India is only the third country, because China has also done it. Alright, there are these countries which have done it. So China also has been a part of it. So that's why saying that only US and Russia would be wrong. So that's why this third statement is not correct. That's why this third statement is not correct. Only the first and the second statements are correct. So correct answer, that's why, will be 1 and 2. Only 1 and 2, these are the two correct statements. Alright, so this is about Gaganyaan. Moving on, the next question is about space debris. Consider the following statements in reference to space debris. 1. Space debris is mostly accumulated in lower Earth orbit. Second, according to International Space Treaty, the countries responsible for creating space debris are also responsible for clearing it. The third is India recently destroyed its own satellite which created space debris. Alright, so these are the three statements given here. Now first and foremost, what do we mean by space debris? What do we mean by space debris? So if you put things into perspective, you'll see that if you just look at the number of satellites that we have been launching, you'll see that the number of satellites have been increasing. We have been increasing the number of satellites that we have launched into space. So that's why with the numbers that are increasing, we see that the amount of junk that we are creating into the space is also increasing. If you consider, let's say 2019, 20 or 21 compared to 2010 or 9, you'll see that there has been an enormous increase in the number of satellites that we have been launching. And mostly these all satellites have been launched into the low Earth orbit. So that's why the number of these space junk, they are increasing in the low Earth orbit. So that's why we might even see a condition where low Earth orbit will become unusable. There are reports and there are scientific reports that are saying that it can lead to a condition where low Earth orbit may become unusable if we not start clearing off the low Earth orbit. Some of the scientists have even said that low Earth orbit has become the world's biggest garbage dump. That so many of defunct satellites or broken away pieces or even smaller pieces like paints which have come off a satellite or a launch vehicle, they all just are there in the low Earth orbit. So that's why this low Earth orbit may become unusable if we don't take steps. So that's why this is something that leads to space junk or space debris. So what do we mean by space debris? Space debris are the debris or the garbage or the junk that we have created in the space. Now some also argue that even things which are natural can be called as a part of space debris, but we should not really call it as space debris because they are in their natural habitat, their natural environment. So there is no standard definition, but naturally or normally what we say is that things which have been created by humans in space, they should be called as space debris and not the ones which are naturally occurring there. So that's why if you just look at the numbers, you will understand that the numbers are huge. That if you just look into satellites versus debris numbers, you'll see that the number of debris have been huge. So for example, there are 2700 working satellites that share their orbits with 8800 tons of space debris. So just understand the numbers, that with this small number of satellites, you have such a huge number of space debris that exist in the space today. So that's why when we put things into numbers, we'll see that the numbers are huge. Now one more thing that you should remember here, a key concept is something called as Kessler's syndrome. Kessler's syndrome. Now what is Kessler's syndrome or Kessler syndrome? So when we look at this word Kessler syndrome, just remember that this is something which is related to the low Earth orbit being unusable because of space junk. So what Kessler or Donald Kessler was a NASA scientist, and what he had said was that there might come a scenario, there might become a scenario in the future where, let's say, a collision between two satellites may lead to a lot many of space debris being created, and all these space debris, there might be other satellites which will again collide with these space debris, and in such a scenario there will be a kind of chain reaction. All right, there will be a kind of chain reaction, and with this chain reaction there might become a scenario where the orbit will become unusable. The orbit, or whether it is the low Earth orbit, most probably it will be the low Earth orbit. The low Earth orbit will become unusable because of this kind of chain reaction. That first collision between two satellites happened, and that led to more of collisions because of all the debris that were created, and then there will be a scenario where this entire orbit will be unusable. So such a scenario where the orbit will be unusable is called as Kessler syndrome. All right. So that's why Kessler syndrome related to clearing of the space orbit or the low Earth orbit is very, very important. So from this perspective, if we again come back to the question, space debris is mostly accumulated in the low Earth orbit. This is correct. That's why I'm saying that scientists are even saying that this has become the world's largest garbage dump. So this is correct. According to International Space Treaty, the countries responsible for creating space debris are also responsible for clearing it. Is this correct? This is not. There is no such treaty. All right. There is no such treaty which says that if you are creating the debris, you are the one to clear it off. There is nothing, at least as of now, as of present, there is nothing like that. So that's why this is wrong. India recently destroyed its own satellite which created space debris. Yes, it did happen. We tested our anti-satellite missiles, and by testing the anti-satellite missiles, we actually created some space debris. India was also criticized for it, that India is creating space debris here, but India said that the way we have conducted the experiments, it will have no effect on the low Earth orbit. So yes, so this is correct that this did happen. So 1 and 3, these two statements given here, they are correct. So the correct answer here will be B, that is 1 and 3 only. All right, moving on, the next question. With reference to radioisotope thermoelectric generator, consider the following statements. The generator uses nuclear energy to generate power. Second, ISRO plans to develop a 100-watt RTG for its deep space missions. Now, first and foremost, what do we mean by radioisotope thermoelectric generator or RTG, and why was it in use? Now, it was in use because of statement number 2, that ISRO is planning to develop a 3-phase of 100 power or 100-watt RTG for its deep space missions of the future. Now, until now, so this is correct. Obviously, this is correct because this is why it was in use. So that's why statement number 2 for sure is correct. Now, let's try to understand what do we mean by RTG. All right, what do we mean by RTG and why has it been so crucial? Now, RTG is what? It is radioisotope thermoelectric generator. Try to break down these words. Radioisotope thermoelectric generator. Now, why is it being called as thermoelectric? Because when we talk about radioactivity, all right, now you might have come across the term radioactivity. I am just doing a quick revision for you about what radioactivity is. So what might happen is that there may be certain elements which are unstable, all right, which are unstable, their nuclei are unstable, and if the nuclei are unstable, they decay, and this decay of nuclei will release some particles, and with these release of particles, some amount of energy and some amount of heat might also be released. So this is called as radioactivity. So radioactivity is what? When an unstable nucleus decays. All right, unstable nucleus decays, and with this decay, the unstable nucleus will emit some particles. These particles are alpha particles, beta particles, or gamma particles. So these particles will be emitted, and with this emission of these particles, energy will also be emitted. So this energy that is emitted along with these particles, they will basically lead to what? A kind of heat energy that will be produced from here. So now look at the word again. Let me take you back to the word that we have. Just break down the word. Radioisotope thermoelectric generator. Radioisotope. What kind of isotope? Radioisotope, meaning that the isotopes which basically will lead to radioactivity, which will show radioactivity. We will use these kind of isotopes, we'll use these kind of nuclei, and the energy that is released from them, the heat energy that is released from them, this heat energy will be converted to electricity. All right. So remember, the heat energy from radioisotopes, will be converted into electricity. This is basically what happens in an RTG, that is radioisotope thermoelectric generator. Now, why are we doing this? For the deep space missions. Now, in general, when we are near the sun, now until now most of the missions that have been taken by ISRO, they are near the sun, in the vicinity of the earth. So that's why solar energy can be used here. All right, they can very easily use solar energy. But when you go away from the sun, let's say tomorrow ISRO wants to launch a satellite or launch a mission for Jupiter, for Saturn, or maybe for the outer solar system or the outer space. There solar energy can't be used, because now you are way away from the sun and the intensity of solar radiation is very weak, and that does not give you usable amount of solar energy. All right, does not give you usable amount of solar energy. So that's not enough for you. So this is where you might have to use other sources, and this other source comes from RTG. So RTG will become the source of energy there. You can say that it is like a battery. All right, it will work like a battery, that you have stored energy, and stored energy from the radioisotopes will be used, so that radioisotope or the heat energy from the radioisotopes will be converted into electricity, and this will become the source of energy. So this is what we want. There are some crucial names of the elements that I would want you to remember. One is plutonium. So one is plutonium, another one is curium. Then you have strontium. Then polonium is also another name, you might remember this. We have polonium and also americium. So these 5 names, just remember these 5 names, because they primarily can be used as radioisotopes for the RTG. All right, these five, they can be used for RTG. They can be used for RTG. So just in case you get a question in your prelims examination, you should remember these 5 names, because these are related to the RTG. So again, if I go back to what the question is, so if you look at the first statement, the generator uses nuclear energy to generate power. Is this correct? Yes, it is correct, because we are looking at heat energy from radioisotopes, which basically is a kind of nuclear energy. This is nothing but nuclear energy, because this energy is coming from where? The energy is coming from radioisotopes. So that's why we can say that this is nothing but nuclear energy. So that's why the first statement, the generator uses nuclear energy to generate power, is correct. ISRO plans to develop a 100-watt RTG for its deep space missions. This is also correct. So that's why both the statements given here are correct. So it's not that only ISRO is trying this. You will see that there are other space agencies also which have been trying to or which have actually used RTGs. So that's why it is not that ISRO is the first such organization to do it, but ISRO now is looking into it, because until now we did not really have a need for RTGs, but now we are looking at a need if we want to develop our deep space missions. So that's why RTG. So that's why remember what exactly we need. So if you just break down this word, you can understand what exactly it is. Thermoelectric. What is thermo? Wherever you have the word therm, it is something which is related to heat. Correct? It is related to heat. So that's why heat is being converted into electricity. So that is what we are doing here. So this is basically, that's why this is correct. All right. Moving on. Next question. With reference to gamma ray bursts, Consider the following statements. 1. It was detected by NASA's Hubble Space Telescope. 2. They are caused by death of massive stars. 3. They are the most powerful events in the universe which can be detected billions of light years away. Gamma ray burst. This is what we are talking about, gamma ray burst. Now when we say gamma ray burst, try to understand what do we see. There are two similar things that we have seen now. That first was fast radio burst. We discussed about fast radio burst in the first question. The second is about gamma ray burst. Now gamma ray burst, what it is? It is a burst of gamma rays. Alright. For fast radio bursts, we did not know what the origin was. But for gamma ray burst, we do know what the origin is. So gamma ray burst, if we consider gamma ray bursts, they originate from supernova, or a kind of supernova which is called as hypernova. A kind of supernova which is called as hypernova. Now, what do we mean? What do we mean by supernova and what do we mean by hypernova? Just understand this, that when we consider a star, there are two types of stars that we consider. Either it would be an average star like the sun, or it could be a massive star which has huge mass, at least more than 1.4 times the mass of the sun. So such a star will be called as a massive star. Now in case of massive stars, what we see is that these massive stars, when they die, when the massive stars die, they undergo something called as supernova. And this supernova is nothing but, you can say, an explosion. Alright, an explosion that happens at the core of this massive star. So this explosion releases a lot of energy, alright, a lot of energy, and this is where we have seen that this is where the origin of gamma ray burst is. So gamma ray burst is happening where? It is happening in the supernova. Supernova, what kind of supernova? A kind of supernova which can be called as hypernova, where hypernova will happen in what kind of stars? Stars that have mass, or stars with mass 5 to 10 times, 5 to 10 times the mass of the sun. Alright, 5 to 10 times the mass of the sun. So with them we'll see that things like hypernova will be observed. So what is it? It is nothing but an explosion that will happen at the core of the star. Alright, an explosion that will happen at the core of the star, because now the core of the star becomes very, very unstable because it is just about to die. So that is where the origin of gamma rays are, or gamma ray bursts are. Now gamma ray bursts, they are said to be the most powerful and the brightest of everything that we observe in the universe. The brightest and the most powerful phenomena that we have observed in the entire universe. So that's why they are so crucial, and that's why we are trying to understand what gamma ray bursts are. So with in case of gamma ray burst, if you again consider these statements, it was detected by NASA's Hubble Space Telescope. Now gamma ray bursts, they have been discovered a long time back, but not by Hubble Space Telescope. So that's why this should not be considered as correct, because the first time it was detected was way back in 1967. There was no Hubble Space Telescope back then. So that's why we cannot say that Hubble Space Telescope. Moreover, Hubble Space Telescope works in the optical range, that is on the visible light, whereas gamma rays, if we have to detect gamma rays, we have to use something that can detect gamma rays and not the visible part, correct? So that's why not Hubble Space Telescope. They are caused by the death of massive stars. This is correct. We discussed that massive stars, when they die, supernova will happen, and supernova can lead to gamma ray bursts. So that's why this is correct. Now, third statement, always be careful. You have an extreme word here. They are the most powerful events in the universe which can be detected billions of light years away. Is this correct? Although there is an extreme word used here, this is correct. We can call it as most powerful. We can most definitely call it as the most powerful and also the brightest. Also the brightest events that we have observed. So that's why from that perspective, this is correct. All right. Most powerful event. So powerful that we say that the amount of energy that is generated by a normal star in its lifetime is generated by a gamma ray burst within seconds, within milliseconds perhaps. So much energy is produced in gamma ray burst, which is equivalent to the entire life cycle of a normal star. So just have this understanding that they are such a huge event. So that's why this is correct. So that's why second and the third statements, they are correct. So correct answer here will be B, that is 2 and 3. All right. Moving on, next question, very simple question. Ryugu and Bennu were recently in the news. What are they? Ryugu and Bennu. We have been asked questions about them. Now these two, you might know that these are what? These are asteroids. Why are they in news? Why have they been news? First, Ryugu, because it was where Hayabusa 2, a Japanese probe, had gone. And second is Bennu. Why has Bennu been important? Because this is where OSIRIS-REx has gone. This is where OSIRIS-REx has gone, and it is collecting samples from there. So if you have seen, this was a very famous video that was released by NASA. So this is the video of OSIRIS-REx going to the surface of Bennu and collecting samples from there. So it just went there, it collected samples from the upper part of the soil from there, and it came back. And this video was viral. And this is something which is a sample collect mission by NASA, and it is collecting samples. It had already collected samples from there, and next year, that is 2023, OSIRIS-REx will be back with the sample that it has connected from this particular asteroid, that is Bennu. Always remember one thing about Bennu, that Bennu is a carbon-rich asteroid. It is a carbon-rich asteroid. All right. So that's why anyway, what are they? They are nothing but they are asteroids. Simple question, but this is what the question is. We are talking about Ryugu and Bennu, which are asteroids. Moving on, next question. With reference to Aditya L1 mission, consider the following statements. All right, Aditya L1, very important event, very important mission. And this year, if you consider this, because when we are talking about Aditya L1, just consider the year 2022 and observe how important 2022 is for ISRO. 2022, just understand how important it is. First, we were supposed to launch a mission for Bhutan for the first time. It is still awaited, about to happen very soon. Second, SSLV, again something which is very new, being done for the first time, a new launch vehicle altogether. Third, Aditya L1, supposed to be launched in the month of maybe September, October this year. Gaganyaan mission, 2 phases, one maybe in June and one in December. And also at the same time, Chandrayaan 3. Chandrayaan 3 is also supposed to be launched this year itself. So Chandrayaan 3, Aditya L1, Gaganyaan mission, SSLV, all the key things, all the key missions being taken by ISRO in one single year. So that's why 2022 from the perspective of missions is also very important, and that's why it is highly likely that even UPSC might pick up a question from here. They might pick up a question from one of these missions that ISRO has been planning or has launched, and perhaps they might ask a question from here. So that's why just understand the importance of 2022. I don't remember any year that will be so remarkable for ISRO as perhaps 2022 would be. So that's why all these missions become even more important, because so many of these missions, they are being taken or they have been planned for this year by ISRO. So Aditya L1, why the name? First of all, why the name Aditya L1? What is the meaning of Aditya? The meaning of Aditya is sun. L1. Why the name L1? Why the acronym L1 being used? So here I want to take you to something which is basic here, which is Lagrange point. Now, if you look at this figure, you'll see that there are 5 points which have been marked here. You have L1, you have L2, you have L3, you have L4 and you have L5. These points have been marked. Now these points, they are very special points, and it's not that these are points which are only present between the sun and the earth. You can observe that. So you have the sun here at the center, you have the sun, and here you have the earth, correct? So between the sun and the earth we have these 5 special points. Now all these 5 special points that we are looking at, these 5 points become very special because they are points of gravitational stability or instability. And these kind of points are observed not only between the sun and the earth, but for any two-body system where one body is revolving around another body. Where one body is orbiting around another body, you would find that these kind of scenarios would exist there. So these kind of scenarios that we are talking about, they produce 5 special points. And that's why these points, why are we calling these special points? Just understand this. So we are saying that this is Aditya L1. Why L1? Because it will be kept at this point, that is L1. So Aditya L1 will be carried to L1 and it will be revolving around the sun from L1. What is the speciality about L1? Why have we chosen L1 as the point where Aditya L1 is being sent? The reason is that L1 is a point which will always have a direct access to the sun. Now, when a point, just understand this, that when a body revolves at L1, it will always keep on revolving at L1. Alright, when a body revolves at L1, it will always keep on revolving at L1 like this. Alright, it will keep on revolving at L1 like this, and it will move as a system. So as the earth goes from here to here, L1 also moves from here to here, L2 also moves from here to here, L4 moves here, L5 moves here, L3 moves here. So this is what will happen, that as the earth moves, the entire system moves. Alright. So the relative positions of L1, L2, L3, L4 and L5, they would always remain constant. L1, L2, L3, L4 and L5, the relative positions of all these 5 points will always remain constant. Alright. So what happens is that this L1 will always have a direct access to the sun. So that's why it becomes a very good point to keep a solar probe, because this is what Aditya L1 is. It is a solar probe. We want to study the sun. We want to study the atmosphere of the sun. We want to study the magnetosphere of the sun. We try to understand various phenomena which are not very well understood about the sun. We want to do everything. Correct? We want to do all that. So for that, L1 becomes a very good point. And that's why L1 is such a crucial point. That's why Aditya L1 is being kept at L1. Now at the same time, also remember why Lagrange point is important, because last couple of years Lagrange point for one reason or the other has been in news. All these points have been in news. Why? One reason is Aditya L1. Second reason is James Webb Space Telescope. Where have we kept James Webb Space Telescope? We have kept it at L2. Again my question, why? Why have we kept James Webb Space Telescope at L2? The reason is that L2 is a point, as you can see in the figure, L2 is a point which is behind the earth. Alright, it is behind the earth. So the radiations of the sun, the solar radiations coming from the sun, the solar radiations will never reach L2. So L2 is a point which is always shielded from the radiations of the sun, because it will always remain behind the earth. So that's why whatever solar radiations are coming, these solar radiations will never reach L2. So that's why any body or any satellite or any mission, any probe that has been kept at L2 will be shielded from the harmful radiations of the sun. That is the reason why we have kept the James Webb Space Telescope at L2, because it becomes easier for us to take the observations of the outer space from L2 without being hindered by the radiations of the sun, without being disturbed by the radiations of the sun. So that's why, to keep it shielded from the radiations of the sun, James Webb Space Telescope has been kept at L2. So that's why L1 has been in news. L1 has been in news. Why? Because of Aditya L1. Because of Aditya L1. Why has L2 been in news? Because of James Webb Space Telescope. Now even L4 has been in news. Do you know why L4 has been news? Because here we found something called as a Trojan asteroid. We'll see what Trojan asteroids are, but we found some asteroids here. There are two asteroids that we have found at L4. One was found way back in 2010. It is 2010 TK7. This is the name of the asteroid which was found at L4. We have found another asteroid recently which is 2020 XL5. So these are the two asteroids which have been found at L4, and very recently, late 2020 it was found, and in 2021 it was declared that yes, this asteroid is at L4 as at Lagrange point. So that's why this is something that is called as which has been found in the orbit, and that's why L4 also has been in news. So L1 has been in news, L2 has been in news, L4 has been news. So it will not be a coincidence if they think that let's ask a question on Lagrange points. So just remember that what are Lagrange points? These are points which have enhanced gravitational attraction or enhanced gravitational repulsion as compared to any other point in a two-body system where one body is revolving around another body. So whether it is between the sun and the earth, whether it is between the earth and the moon, or whether between any planet and its satellite, everywhere we would have all these Lagrange points. So that is why Lagrange points are important from that perspective. Also, if we consider Aditya L1, Aditya L1 is very, very important because of the fact that this is where we are going to the sun. We are, not going to the sun, rather, not like Parker Solar Probe, but we are going near the sun, and we will try to observe the sun from there. We will try to understand various phenomena which are related to the sun, which in one way or the other have not been very well understood. So we will study the sun's corona, that is true. We will also study the magnetic field of the sun. We will try to understand the temperature variation on the sun. Now this is also very, very unique about the sun, that when we consider the sun, the core of the sun has a very high temperature, because that is where all the nuclear fusion reactions are happening. So that's why the core of the sun has a very high temperature. Almost 15 to million degrees Celsius is what the temperatures could reach at the core of the sun. Now as you come out of the core of the sun, obviously you have come away from the source of energy, so the temperature starts to fall. By the time you have reached the surface of the sun, the temperature at the surface of the sun is merely 5000 to 6000 degrees Celsius. Alright, only 5000 to 6000 degrees Celsius. But as you move out, when you are at the atmosphere of the sun, you would expect that the temperatures would fall further. Right? Temperature should fall further, but that doesn't happen. What really happens is that the temperature starts to rise. There are two parts of the sun's atmosphere. Right? If we consider the solar atmosphere, there are two parts to it. One is called as the chromosphere, and the second one is called as corona. So first comes chromosphere and then comes corona. Now chromosphere, by the time you reach chromosphere, the temperature at the surface, as I told you, the temperature at the surface was almost 5000 to 6000 degrees Celsius. Now as we are going away, as we are going out of the sun, this is where the temperature now increases again, and at the chromosphere the temperature could be almost 50,000 degrees Celsius. But as you go even outward towards the corona, the temperature even rises further. Temperature can go up to lakh or 1.5 lakh degrees Celsius, which is unique. It can even reach temperatures higher than that, which is very exceptional. So we do not really know what happens here. The temperatures will be very high, and because the temperatures are very high, it should actually drop. We do not have a very strong understanding of why this happens. There are various theories that this is why it might happen, but we do not really have an exact answer to why exactly something like this happens. So that's why this is also one of the key areas that Aditya L1 will try to understand. So that's why it will study the sun's corona. Alright, it is ISRO's first space-based astronomy mission. Can we say that? We can't, because we have to also consider AstroSat as the first space-based astronomy mission that was taken by ISRO. So that's why that cannot be said to be true. It will study the sun's corona. It is true. Ground support for Aditya L1 will be provided by Ares. This is correct. And we have seen for other satellites also, ground support is carried by Ares, which is an observatory which is located in Uttarakhand, and through that we actually provide ground support to some of the missions. So that's why this is correct. So statement number 2 and statement number 3, they are correct. The first statement is wrong. So if we consider the statements which are given here, we see that the first statement is wrong, second and third are correct. So which of the following given statements are incorrect is what has been asked here. So correct answer should be 1 only. By mistake we have not taken this. This should be considered as correct, that the correct answer is 1 only. Only one statement given here is correct. That incorrect, that is, it is ISRO's first space-based astronomy mission, which is not correct because it was AstroSat, which was India's first space-based astronomy mission. Alright, so this is what AstroSat, this is what Aditya L1 is. So just understand all these basic areas about AstroSat, about Aditya L1, because it is not only about Aditya L1 and the objectives of Aditya L1, but all these peripheral concepts also are equally important. So please make sure that you understand all these concepts as well. Moving on to the next question. In the context of Chandrayaan 3, consider the following statements. 1. It will consist of a lander and a rover. Then to communicate with the Earth, it will use the orbiter from Chandrayaan 2, and it will study the darker areas of the moon, subsurface and exosphere. Which of the statements given above is or are correct? Now what is Chandrayaan 3? Just understand this, that when we launched Chandrayaan 2 had 3 parts. Alright, what were the 3 parts? We had a lander, we had a rover, and we had an orbiter, correct? These were the 3 parts of Chandrayaan 2, correct? These were the 3 parts of Chandrayaan 2. Now what happened with Chandrayaan 2 was that the orbiter was successful. Orbiter is still working, it will keep working in the coming years as well. But what happened with the lander and the rover is that lander and the rover just a couple of minutes before landing on the surface of the moon, it lost its contact with the Earth. It's lost its contact with the Earth, and because of the lost contact, ultimately what happened is that it crash landed on the surface of the moon. So just the last couple of minutes is where we lost the contact, and because of the lost contact, this is a part of Chandrayaan 2 mission which was unsuccessful. So because this was the part which was not successful, what we decided as a part of Chandrayaan 3 is that the part that was not successful will be launched again, and we will try to land on the surface of the moon again. And this is what Chandrayaan 3 mission is. The part which was successful, that is the orbiter part, will not be launched again, but the part which was not successful, this is the part which will be launched again. And that's why with Chandrayaan 3 we are launching the lander and the rover again. Now what do we mean by lander and the rover? Lander is something which is supposed to land. Alright, lander is something which is supposed to land. So anything that is just supposed to land on the surface of a celestial body, it will be called as the lander. And if it is supposed to move around, then it will be called as a rover. So any rover mission is the mission which is supposed to move around on the surface of the celestial body, and any lander is something that is just supposed to land, just like a helicopter, you can say. The helicopter just lands somewhere, correct? So just like that, a lander is supposed to just land and rover is supposed to move around. That's the basic difference between a lander and a rover. So in the context of Chandrayaan 3, consider the following statements. It will consist of a lander and a rover. This is correct. To communicate with the earth, it will use the orbiter from Chandrayaan 2. This is also correct, because as we discussed that the orbiter is still working. So that's why this orbiter can be used for Chandrayaan 3. Then it will study the darker areas of the moon's subsurface and exosphere. This is correct, that it will try to do that. Now what do we mean by darker areas? So what happens is that you might know that moon has many craters, correct? The moon has many craters. Now with these craters, what happens is that many of these craters are such that the sunlight has never reached the crater, all right? The bottom of the crater has never been visited by the sunlight. So this is what has happened, that this kind of an area, this is never been visited. This has never been visited by the sun rays. So that's why these areas have been dark. They have been in the dark for billions of years, from the time that the moon has existed. So that's why we want to study these areas, try to understand the mineralogy of these areas, the topography of these areas. At the same time, many of these areas in the north and the south pole, these hidden areas, they also have water ice. They are also the areas where water in the form of ice is present on the surface of the moon. So we also want to understand that, all right? We also want to understand that and look into those compositions. So that is why we are saying that it was trying to study the darker areas of the moon. It is trying to study the darker areas of the moon. So that's why this is also correct. So which of the statements are given here are correct? All the three. All the three statements given here are correct. So that's why 1, 2 and 3 are correct. Moving on, the next question, Trojan asteroid seen in the news is what? Now, Trojan asteroids, the name that we have here is Trojan. We just discussed, if you remember, we just discussed about the fact that we have two asteroids which are at L4, right? They are situated at L4. Any such asteroid which has associated itself with the orbit of a planet will be called as a Trojan asteroid. So in that sense, you can say that Earth has two Trojan asteroids. Earth has two Trojan asteroids. The number of Trojan asteroids on Jupiter, for example, is much higher, because Jupiter is just next to the asteroid belt. So that's why there are many asteroids which have dislodged themselves from the asteroid belt and they have landed in one of the Lagrange points of Jupiter. So that's why Jupiter has a larger number of these Trojan asteroids as compared to any other planet. Earth has two, Jupiter has many. Now, so that's why when we say Trojan asteroid, now look at the options that you have. Intergalactic bodies, no. Debris in low Earth orbit, no. Constant companion to planets in our solar system, yes, they are. Why are they constant companions? Because they have been fixed, right? They have fixed themselves where? They have fixed themselves in the Lagrange point. So they will remain at the Lagrange point. So they will remain in the Lagrange point and they will keep revolving around the sun being at the Lagrange point. So that's why we are saying that they are constant companions to the planets in the solar system, or in other words, you can also say that they have infiltrated the orbit of a planet, all right? They have associated themselves with the orbit of a planet. So these are called as Trojan asteroids. So that's why statement, the first statement given here can be considered as correct. Now another, just remember one more thing, there is another mission called as the Lucy mission. There is a mission called as Lucy, which is supposed to be launched by NASA next year, that is 2023. And this Lucy mission basically is to study, it is supposed to study the Trojan asteroids of Jupiter. All right. So that's why Trojan asteroids have been in the news because of this particular mission as well. All right. So two reasons why Trojan asteroids have been in news. One, the discovery of 2020 XL5 in our L4, Earth's L4, and then the Lucy mission. Because of the Lucy mission also, Trojan asteroids have been in news. So that is what they are. Moving on, the next question, consider the following statements with respect to geomagnetic storm. They are caused by higher than normal levels of radiation coming towards the earth from the sun. Second, they cause a disruption in earth's magnetosphere. And 3, the frequency of these storms vary with sunspot cycle. Alright, so which of the above are correct is what has been asked. Now geomagnetic storms, you might have seen that they were in news in the month of April, and they often are in news anyway as well. When we talk about geomagnetic storms, just try to understand what do we mean by geomagnetic storms. So geomagnetic storms, if you look at the essentials, or if you try to just understand what space weather is, now many a times what happens is that solar winds will be emitted from the sun. Alright, solar winds will be emitted from the sun, and these solar winds, they are magnetic in nature. They might be produced because of some kind of magnetic anomaly on the surface of the sun. So they are called as what? They are called as solar winds. Now these solar winds sometimes can be very strong. Sometimes they can be very strong, and they will interfere with the magnetic field of the earth, the magnetosphere of the earth. So in a manner, what happens is something like this. You will see that we have a magnetic field like this. Now what happens is that because of the solar mass or coronal mass ejection, we will see that solar winds will be emitted from here towards the earth. So because of these solar winds which are emitted, we will see that it will interact with the magnetic field of the earth, and if they are very strong, if they are strong enough, they can disrupt some of the services of the satellites or the communication systems on the earth. They can even disrupt the electricity supply on the earth if they are very strong. But usually they are not that strong, and also magnetosphere of the earth is also very strong. So it is able to withstand the magnetic storm of the sun. So if you have heard of auroras or the northern lights, aurora borealis basically happens because of the interaction between the magnetic field of the sun and the magnetic field of the earth. So geomagnetic storm. So geomagnetic storm was in news in the month of April, that a very strong geomagnetic storm was coming near the earth, had come near the earth, and because of that we saw that geomagnetic storm was in news. Now when we say geomagnetic storm was strong, the strength of geomagnetic storm basically goes from a scale of G1 to G5. G5 obviously being the strongest. Now this geomagnetic storm in the month of April, this was in the range of G1 to G2 only. So even in the range of going only up to G2, we were still saying that it was a very strong geomagnetic storm that was heading towards the earth. So that's why this is what geomagnetic storm are basically produced because of the interaction between the magnetic field of the sun and the earth. So if you look at the options again, they are caused by higher than normal levels of radiation coming towards this towards the earth from the sun. This is correct. That the radiations which are being carried from the sun, they are the reason for the geomagnetic storm. This is correct. They can cause a disruption in Earth's magnetosphere. Yes, they can, and that's why they can even lead to interruptions in the satellite services, in the communication services, etc. as well. Then after that, the frequency of these storms varies with sunspot cycle. This is correct, or something that can also be called as the solar cycle. Now we have two terms here, one called as solar minima and other one called as solar maxima. So whenever we have solar maxima also means that the activities on the sun are very strong. They are at their maximum, at their peak. So that's a solar maxima. So whenever we have solar maxima, the chances of these magnetic storms coming out of the sun are also higher. So that's why the instances of geomagnetic storms will also be higher when we have solar maxima. So that's why we say that it also varies with the solar cycle, also varies with the sunspot cycle, because all these things are related to one another. So that's why yes, this also is correct. So that's why all the three statements which have been given here, all the three statements are correct with regards to the geomagnetic storm. Alright. Next question, consider the following statements with respect to Indian Neutrino Observatory. So Indian Neutrino Observatory, so you might know that we are building our own neutrino observatory, but where are we building it? We are building it near Madurai in Tamil Nadu. So because it is in Tamil Nadu, you cannot say that it is in Andhra Pradesh, so that's why first statement definitely is not correct. Alright, first statement is not correct. Second statement, neutrinos are neutral subatomic particles and they are only affected by electromagnetic force. Now when you have neutrinos, I'll just give you some basics about neutrinos because neutrinos very often are also in news. So when we are looking at neutrinos, few things. Most important thing, just remember this, just one phrase with regards to neutrinos. They are chargeless, and they are massless for all practical purposes. They are chargeless and they are massless. Now when we say chargeless and massless, so first of all what happens is that in their structure, alright, in their structure, remember that in their structure they are very similar to, in their structure they are similar to electrons. They are similar to electrons, but they do not carry any charge. Alright, in their structure they are similar to electrons, but they do not carry any charge. And also if you look at a freely existing subatomic particle, there is no other subatomic particle which is such a high in number, which is so high in number as compared to neutrinos. If you consider the entire universe, almost 0.3% of the entire universe is just nothing but neutrinos, almost 0.3% of the universe. Now this is a big number. You might think that okay, 0.3%, so this is nothing, but it's not nothing, because all the stars in the universe, I told you before, all the stars in the universe taken together is just 0.5%. So compared to that, when we are looking at a number which is 0.3%, it is a very significant number. So that's why number of neutrinos, the freely existing neutrinos in the entire universe is huge. They are also produced in many, they have existed ever since the birth of the universe. So that's why they are very important. That's why the study of neutrinos is also very important, because they would give us an insight about the early universe. They might give us an insight about the early universe and how they have existed all throughout the universe, all throughout the history of the universe. At the same time, they would also be produced in the nuclear reactors. Alright, just remember that they can also be produced in nuclear fission reactors. We have seen that nuclear fission reactors, the nuclear reactors that we have in the world, they are also a source of neutrinos. At the same time, they have existed since the birth of the universe. So that is why everyone is so keen on understanding the neutrinos, understanding of what neutrinos are and how they interact, how they behave. So that's why neutrinos have been very, very important, very crucial from that perspective. From the perspective that we know that they have been here for a very long time, and they have always been here since the time of the birth of the universe. So that's why they are considered to be so important from the perspective of the research about the origin of the universe. Alright, so from that perspective we are looking at looking at the neutrinos. Let's move back to the question. Observatory is in Andhra Pradesh? No, not true. Neutrinos are neutral subatomic particle. Yes, they are. Consider this: chargeless, massless. So because they are chargeless and massless, of course they are neutral. So that's why 2 definitely is correct. Third statement, they are only affected by electromagnetic force. Now, can they be affected by electromagnetic force? Remember again, most important phrase, chargeless, massless. If they are chargeless, can they be affected by electromagnetic force? They can't be. they can't be affected by electromagnetic force. So that's why when we are looking at them, when we are looking at neutrinos, neutrinos cannot be affected by electromagnetic force. So 1 is wrong, 3 is wrong. What is correct? 2 is correct. So that's why the correct answer here will be 2 only. What is the force that can affect them? The only force that affects them is weak nuclear force. All right, they are, I'm just adding another point, they are affected by weak nuclear force. They are affected by weak nuclear force. They are not affected by strong nuclear force. They are not affected by gravitational force. They are not affected by electromagnetic force. Can't be affected by gravitational force. Why? Because they are massless. Can't be affected by electromagnetic force. Why? Because they are chargeless, and they are even not affected by the strong nuclear force. They are only and only affected by the weak nuclear force. So always remember this about them. So that's why in such a scenario they become you can say closer to the electrons, because even electrons are not affected by strong nuclear force, but they are affected by the weak nuclear force. But of course electrons, because they carry a charge, they will be affected by the electromagnetic force. But in the structure, just remember this, don't need to go into the quantum details of why we are saying that they are similar in structure to electrons, but just remember that they are similar in structure when it comes to the electrons. So from that perspective, neutrinos in general will be important, not only from the perspective of the fact that they are we are building our own neutrino observatory, but at the same time they are very crucial particles that have existed in the universe since the time of the birth of the universe. So that's why they are, and they can just pass through. They can pass through the earth without being distracted by anything, because they are chargeless and they are massless. So they are just like ghosts. These are ghost particles, that these ghost particles can just move around here and there without doing anything, without affecting anyone, without doing anything anywhere. So that's why they are so crucial particles, and that's why we want to understand what these particles are. All right. Moving on, the next question. Consider the following statements. Supermoon is full moon at apogee. Blood moon occurs at total lunar eclipse, and blue moon occurs twice a month. Which of the following given statements are correct? So these terms, once in a while they will be in news, so you should just understand what do we mean by these terms. First is supermoon. All right, first term is supermoon. So when we say supermoon, supermoon basically is the condition where you have the biggest size or biggest appearance of moon. Moon at its biggest appearance will be called as supermoon. So when will supermoon happen? When will something appear to be bigger? When it is near to you. So near means what? We have 2 points in the orbit. So for example, if we consider the Earth's orbit, let's say if this is the Earth and this is the orbit of moon, all right. So this point is the farthest point, correct, and this point is the nearest point, right. So farthest point is called as what? It is called as apogee. And what do we call the nearest point? We call it as perigee, correct. So perigee is the nearest point and apogee is the farthest point. Now, can something appear to be the biggest when it at the farthest point? The answer is no. When will it appear to be the biggest? When it is nearest. So where it should be when supermoon has to appear? It should be at perigee. Look at the first statement given. The first statement says what? Supermoon is full moon at apogee. No, it is the full moon where? In perigee. All right, at perigee. So that's why one definitely cannot be correct. One definitely cannot be correct. Blood moon occurs at total lunar eclipse. Why do we call it as blood moon? Because it appears red in color. Because of its reddish appearance, we call it as what? We call it as blood moon. So blood moon appears at total lunar eclipse. Is it correct? This is correct. that this is what it is, that this is where we have blood moon. And then after that we have blue moon. So about blue moon, what it is written is that blue moon occurs twice a month. Blue moon. There is this saying that you might have heard, once in a blue moon. When do we use the term once in a blue moon? If there is something that happens once in a while. So then you will say that this is once in a blue moon. So when we say once in a blue moon, we use it because that this is a very rare event. So here also this is very rare event. What is rare? The rare event here is that we know that for one revolution of the moon to complete around the earth, it takes almost 29 days, right? It takes almost 29 days. So what happens is that once in 29 days, we have a full moon, correct? We have a full moon. So generally what happens is, because you have a month of 30 days or 31 days, most of the times you see only one full moon in a month. But sometimes once in 2.5 years, what happens is that, let's say, one full moon will happen on the 1st of the month and second full moon will happen on the 30th or the 31st of the month. So then in that case, what has happened? 2 full moons in 1 month. So when 2 full moons happen in 1 month, what we call it as is blue moon. So blue moon does not mean that it appears blue in color. So please don't confuse here, that blue moon does not mean, see, blood moon, I understand that blood moon means that it has a reddish appearance, but blue moon does not mean that. Blue moon means that there are 2 full moons that have happened in one single month. So then we will call it as a blue moon. So that's why it does not occur twice a month. It is a phenomena where 2 full moons will happen in 1 month. When we have 2 full moons in 1 month, we will call it as a blue moon. So that's why this is also not correct. So first statement wrong, third statement wrong, the only correct statement is second statement. So that's why the correct answer here will be C, that is 2 only. So that's why this is the correct statement here, that is 2 only. So because they have been in use very frequently, so maybe you can consider this as an important question. Consider the following statements regarding China's Chang'e 5 probe. It was a Mars exploration program. Second statement, China has become the second country after US to bring samples from the mission. The mission was named after China's ancient moon goddess, and it was launched through the Long March 5 rocket. Now Chang'e 4 or Chang'e 5. All these missions, when we look at these missions, just understand that these missions are related to what? These missions are related to the moon. These missions, they are related to the moon. Now when we look at these missions, if you look at the first statement that we have here, the first statement is that it is a Mars mission. Alright, it is a Mars exploration program. This is not correct because it is related to what? It is related to the moon. Because it is related to the moon, it is definitely wrong. So first statement for sure is not correct. Second statement, China has become the second country after the US to bring samples from the mission. Now bringing back samples is not something that has been done only by the US. It has also been done by Russia, correct? It has also been done by Russia. So that's why we cannot say that it is only after US that somebody has done it. So that's why this is also wrong. This statement is also not correct. The third statement, the mission was named after China's ancient moon goddess. Now this actually is correct. That's why Chang'e missions, all the Chang'e missions, you'll see that all these missions, they are related to the moon. Whether Chang'e 3 or 4 or 5, they all have been in use, they all have been successful for China, and they all have been named after the ancient goddess for moon. So that's why this is correct. It was launched through Long March 5 rocket. This is also correct, that these two statements are correct. So which of the following are correct statements? Statement number 3 and statement number 4. These two statements given here, these two statements are correct. So that's why from the perspective, just remember this. Now when it comes to these missions, one thing that is very, very important about these missions is also to understand, have a basic understanding about the moon. Now for moon, you might have heard that there is a term which is used. We have the near side of the moon and we have the far side of the moon. We say that the moon has a near side and a far side. Now, when we say near side and far side, what do we mean? And then there is another concept which is also important here, which is called as tidal locking. Another term which is important is tidal locking. So, near side, far side and tidal locking. These three terms we should understand. Now, what happens with the moon is something very unique. That moon revolves around the earth in the same time period as it takes to rotate around the earth. So, the period of revolution and the period of rotation of the moon is equal. So, moon has equal rotation and revolution periods. Alright. Now, because of this what happens is that the moon only shows one face to the earth. It only shows one side to the earth, because if, let's say, if you consider this as the earth and the moon is rotating and revolving at the same time with that same speed. So, what happens is that it always presents only one face. It always presents only one phase as it moves around the earth. So, that's why in this scenario what we say is that in this scenario the rotation period and the revolution period of the moon is the same. Now, is this a coincidence? Is this something that is happening just by chance? The answer is no. It is not something that is happening just by chance, because in this scenario what happens is that when we consider the rotation and the revolution period of the moon, we see that both the rotation and the revolution period of the moon is something that is supposed to be like this, and not only for the moon, but it is something that will happen with any two-body system. Yes, it has not happened with every two-body system, but ultimately one day, maybe billions of years from now, it is supposed to happen for every body or every two-body system. So, even for the earth and the sun, right now we know that our rotation period is only 24 hours and revolution period is 365 days. So, right now it is, but there will be a time in future where our rotation and the revolution periods will also be the same. That we will also only present one side to the sun and the second side will not be presented to the sun. So, if that happens, obviously it will not happen in our lifetimes. It is supposed to take billions of years before this happens for the Earth-Sun system, and by the time this happens, I think life will already be done, because the sun would have already been done. So, fortunately for us, fortunately for our future generations, this is not supposed to happen for the earth in any time soon, but it is supposed to happen for any two-body system, remember this. So, it is not that it only happens with this, with our earth and moon. Even if you consider Pluto-Charon system, Pluto and its moon, that is Charon. In this system also we have seen that something similar can be seen, that here also the rotation and the revolution periods are the same. So, it has happened there also, and that is why we have these two concepts of near side and the far side. The side that we are able to observe is called as the near side. So, whether you are at this side of the longitude or the other side of the longitude, whether you are sitting in India or whether you are sitting in the US, you will see only one side of the moon. The second side not available, not visible. So, with China, what China has tried is that they are going to the far side of the moon, the other side, the unexplored side of the moon. So, that is why this is very, very unique, because until now no other country has been able to do it. Even Israel tried. Israel also had sent a mission which wanted to go to the far side of the moon, but they did not succeed. But with China, they have succeeded in doing this. They have been able to go to the far side of the moon, which is again very unique about the Chang'e missions. So, and this phenomena where you see only one side is called as tidal locking. This is something which is called as tidal locking. So, because of tidal locking this has happened, alright. Because of tidal locking this has happened, that the moon only presents one side to the earth and does not show the other side. So, whenever tidal locking happens, wherever tidal locking happens, in any two-body system, wherever tidal locking happens, something like this will happen. And this tidal locking basically happens because of the gravitational pull of the central body. This happens because of the gravitational pull of the earth. It basically slows down the rotation of the moon, and that's why rotation and revolution periods become the same. That is where it becomes stable and it keeps on then revolving around the earth. So this is basically what happens, and that's why you have this phenomena which is called as tidal locking. So tidal locking is not something that has happened only for the moon earth system, but it will happen in any two body system. Alright, next question, the last question from the side of the space technology, and a very important question I would say, because these kind of questions are often asked. Because see, what happens is that the major missions that we have, the major Indian missions, about them you need to know in detail. But apart from that, there are certain international missions which have been launched over the course of last 1 year or so, and these kind of missions, you need not go into the details of these missions, but in one line you need to know about them. You just need to know about one key aspect of what they are, what this mission is. That's it. You need not know about the details of what technology has been used, how they are doing, what they are doing. No, not required. But the basics are required, that what exactly is that mission. So these kind of questions can come where they could just give you the name of the mission, and they can ask you the objective of that mission. Alright, so first is Artemis, first woman and first person of color on moon. Is this correctly matched? Yes, this is correctly matched. Gaganyaan mission, to demonstrate human space flight. Is this correctly matched? Yes, of course, this is also correctly matched. Then you have the DART mission, to change the position of International Space Station. No. What is DART mission related to? DART mission is related to repositioning of the asteroids, because what may happen is that we might see that in the asteroids, it is something that there are many asteroids which have come very near the earth, all right, which might have which might create a condition where they might come towards the earth, and this can become dangerous for the earth if they start traveling towards the earth. So the DART mission basically is to take care of these kind of asteroids which can potentially become harmful for the earth. So that's why DART mission is related to that. So nothing to do with International Space Station. So 3 definitely wrong. So 1 and 2 are correct, 3 is wrong. If you look at the options that are left out, you have only one option that can be correct, that is C. So the fourth option, the fourth statement, Dragonfly mission to collect samples from Saturn's moon, that is Titan, this is also correct. So what is correctly matched? 1, 2 and 4, these 3 are correctly matched. So, and this is how questions actually can come about missions which are not very important. So that's why for these kind of missions which are seemingly not very important, just know one line about them, not more than that. That would be enough for your examination. All right. Now there are 3 questions that we have, last 3 questions which are left, which are related to artificial intelligence and robotics. Smaller questions, will not take a lot of time. First is, consider the following statements about soft robotics. 1, they are constructed from highly compliant materials. 2nd, they are more flexible and adaptable in finishing their work around humans when compared to regular robots. 3, they can be used in prostheses and artificial organs. Now soft robotics, the first statement that you see, they are constructed from highly compliant materials. This is something that you can take as definition of what soft robotics is. That when we are using highly compliant materials, these kind of robotics or this robotics will be called as soft robotics. Now soft robotics has gained some importance. So that's why even if you have not seen this in the newspapers, in the technology world, soft robotics in the last couple of years, in the last 3-4 years rather I would say, has been very important, has been a key concept that the industries have been working on, that they want to use these kind of materials. Also, if you have heard of this term, that is bio-inspired robots. Bio-inspired robots. So bio-inspired robots is where we are inspiring or we are taking the inspirations for robotics from the living world, from the organisms. So for example, let's say conversion of energy coming from the batteries into mechanical work. So that is to be done by a part of the robot which is called as an actuator. So we want to develop better actuators. Where can we get the inspiration for actuators? From the muscles of the organisms, or let's say from the animals which use energy very efficiently. Let's say carnivores, for example. So carnivores know how to use the energy, the stored energy, very efficiently through their muscles. So we want to understand how they do it so that we can replicate the same in the actuators which are used in the robots. All right. So that's why this is nothing but where we are trying to take inspiration from the living world, from the organisms, from the animal world maybe. So that's why they are constructed from highly compliant materials. This is true, and they actually can be called as, or can form the basis of bio-inspired robots as well. They are more flexible and adaptable in finishing their work around the humans when compared to regular robots. This is also true, because this is how we are trying to train them. This is how we are trying to construct these soft robots, or robots which are called as a part of soft robotics. And then they can be used in prosthesis and in artificial organs. Yes, they can be. And that's why we are saying that they are bio-inspired robots and also a part of bio-hybrid robots. They are also related to bio-hybrid robots. So that's why these terms, just remember that these terms have been in use in one way or the other. So that's why maybe you may not have seen them as a regular part of your current affairs or regular part of your newspaper articles, but still in the industries they have been very important. So that's why knowing about them is very, very important. So that's why all these three statements given here about soft robotics, they are correct. Moving on, the next question, xenorobots or xenobots. Simple question, have been in use in last 3-4 years. Xenobots are self-replicating robots, self-destructing robots, robots to kill other robots in case of malfunction, robots developed for space missions. What are xenobots? Xenobots are self-replicating robots. What have we done with xenobots? You might have come across this, that we have used what? We have used cells from frogs, and cells from frogs have been used to make these kind of robots which are xenobots. Now with xenobots, they again, of course, they are also bio-inspired robots, because we have taken cells from frogs and we have constructed the xenobots. At the same time, what is very peculiar about xenobots is that we are saying that these are self-replicating robots. In a manner, we are saying that many say that they are capable of reproduction. They are capable of reproduction because they are cloning themselves. They are cloning themselves, because that's why we are saying that they are self-replicating robots, because they are capable of cloning themselves. So that's why we are saying that these are self-replicating robots, and that's why xenobots have been so crucial, because many even are considering, should we call them as living, should we call them as dead, should we call them as machines, should we call them as organisms, because the way the xenobots have been made. So that's why very interestingly these are self-replicating robots. So this is the first statement that you have here. The first statement is correct. Coming to the last question, AI research supercluster and AI supercomputer is being developed by which tech giant? 4 options: Google, Microsoft, Apple and Meta. You might have again come across this. This is being developed by Meta. What are they trying through this? They are trying to build a supercomputer using artificial intelligence, which they consider would be the fastest supercomputer of the world. Currently, you might know that there is a supercomputer known as Fugaku, and Fugaku in Japan is the fastest supercomputer of the world currently. But what Meta is trying is that with the help of artificial intelligence, they want to build a mechanism, they want to build a supercomputer which may become the fastest supercomputer of the world. So this is basically what is being tried through this particular project, that is supercluster, and this is basically something that has been taken as a project by Meta. So this is what it is. So this is the end of the session for today. We have taken 2 crucial parts. One obviously related to the space technology, which is always the biggest part of your preparation, because number of questions in the past and expected are always the biggest when it comes to space technology. And we have taken some questions from artificial intelligence and robotics. We'll again be back tomorrow the most crucial part that we'll take in tomorrow's class will be from the world of energy, and apart from energy we will take some of the crucial parts related to other areas as well. So this is what we have in store for tomorrow's class. Till then, please go back, revise. It's not only about revising all the topics or the questions that we have seen here, but also some of the key areas which are related to these questions. I have given you some of the keywords, some of the areas related to these questions from where there are possibilities of questions being asked. So please make sure while you revise these topics, while you go through all these areas, you also revise all these areas which are associated with what we have discussed here. So with that, I'll take your leave. Thank you and good night.